Audio Jungle.
From the ancient civilization eating records onto stone tables to today's interconnected digital networks, our journey has been defined by our quest to understand and leverage information. This evolution has now brought us to a forefront of AI-driven technologies to anticipate our needs in real time. Today, as we delve into the realm of AI-driven smart query assistant for dynamic database interaction, we stand at a pivotal intersection of innovation where the power of data and technology converge to redefine how we interact and leverage information. So I am DINALI KOHOMBANARACCHI, and this project is proudly undertaken as my final year research project under the advice of our senior lecturer, Dr. D.S.H. Maitripala in Faculty of Engineering, University of Peradeniya. Here is a roadmap of the key elements we are exploring today in this video. In this project, we are addressing a crucial challenge faced by many businesses today: how to make complex database interactions simple, intuitive, and accessible to everyone. Imagine a user who wants to retrieve detailed company data but doesn't know SQL or database query languages. Our AI-powered conversational assistant bridges this gap. Here how it's works. A user input a question or request in natural language just like they would in regular conversation. This input is processed by a large language model, simply we call as LLM, through an API which translates the new natural language query into a structured database query. This flowchart outlines the process flow of the solution I am proposing, illustrating how various components interact seamlessly to deliver a user-friendly and efficient system. The process brings with the user who inputs a query in natural language. This input is sent to an API, which acts as the intermediate between the user, the backend system, and the AI. The API processes the user's request and passes it to the OpenAI LLM, which interprets the natural language input and maps it to a predefined SQL query template. The API then forwards this query to a Django ORM, which provides a secure and efficient mechanism to interact with the database. The Django ORM translates the query into a form understandable by the database and retrieves the relevant data. This data flows back through the Django ORM to the API, where it is formatted into a conversational response. Finally, the response is presented to the user in the given chat space. So we can focus on the key tasks accomplished before the feasibility analysis. To date, significant progress has been made across various aspects of the project. As a start, a test interface has developed successfully as shown in this slide. The development environment has been successfully set up by configuring Django for backend development and SQLite as the database. Additionally, essential libraries including the LLM API and Django Reset Framework have been installed to support system functionality. In backend development, a Django project structure has been established, with an API app specifically designed for handling user queries. So, when we move on to the detailed feasibility analysis of the given solution, we can discuss in separate areas of the feasibility. In technical feasibility, the project is built on a technically feasible foundation using established tools and frameworks. Django ORM simplifies database management while ensuring scalability and security. LLM models provide state-of-the-art natural language understanding capabilities, allowing accurate and contextual appropriate responses. The seamless integration of front-end, back-end, and the AI components ensures the system operates efficiently and handles future expansions. In financial feasibility, cost-effective tools have been utilized to keep the project financially feasible. In innovation feasibility phase, the project includes the innovative elements by combining AI-driven natural language processing with traditional database query. The system modular design supports the scalable and adaptability, allowing the addition of new database tables and more complex query logic in the future as well. So, user accessibility and ease of adoption have been prioritized through the project. So, the user-friendly interface ensures even non-technical users can interact with the system effortlessly. So, therefore, we can analyze the feasibility of the selected project under above criteria successfully. Despite the innovative approach and technological foundation in this project, there are notable knowledge gaps that need to be addressed to ensure the system effectiveness and reliability. First one is understanding context in natural language queries. So it was major talent like in accurately interpreting and mapping user query to predefined SQL templates. And also, multi-turn consensus support was another knowledge gap. Implementing multi-turn conversational is crucial for enabling consensual continuity. However, ensuring that the system remains in necessary context from previous interaction and correctly applies to subsequent query is complex task. So there is knowledge gap in designing an efficient context management framework in align with LLM's capability and database query logic. Another one that can I mention is dynamic SQL template generated. While predefined SQL templates are suitable for structured queries, the system currently lacks the ability to dynamically create templates for novel or unforeseen users' inputs. So another one is database schema adaptability. Project currently focus on predefined tables with fixed schemas. However, real-world databases are often dynamic with changing schemas and evolving data structures. So, addressing these knowledge gaps will enhance the system's ability to handle real-world complexities, improve its scalability, and ensure robust security performance. So, another important thing that we should focus on this project is the innovative methods that I have used throughout this project.
So as shown in this video, we can focus on the key innovations include API key integration, Django ORM for SQL queries, dynamic SQL templates for personalized responses, using .env files for safeguarding sensitive data, and so on. So throughout these innovative methods, we can access for the key features that we are focusing on this project.
As a conclusion, in a world where data is concerns of decision making, the project bridges the gap between complex database systems and user-friendly interaction.